Data structure can be homogeneous, where all elements are of the same data type. And we discussed data types in our previous lecture. Data structure can be heterogeneous, where all elements can be of more than just one data type, a mixture. So look at the dimensional level, one-dimensional level. Homogeneous data represent vectors. Heterogeneous data represent lists. On two-dimensional structure, we have matrix for homogeneous, the same data type structure, and DataFrame for heterogeneous. And finally, more than two dimensions, we have arrays. So when you work on your data and you know what type of data is, you can define what type of data structure you need to build. Let's start with a simple, one-dimensional, homogeneous data type, vectors. To build vector, you would use C function, which is a combination of elements separated by commas. It can be numeric, it can be characters, but remember the data type has to be homogeneous. What would happen if we combine different types in a vector? R will reinforce different types to a single type. Let's look at this case where we have a vector with three elements, a number, a character, and logical. So R convert everything in a vector into a character. We have four different ways to create vector depending on your goals and needs. So the first and the most common is C function, where you combine different elements separated by comma, but you can also create a vector using colon in case if you need consecutive numbers or consecutive letters. You can use sequence, seq function, where you define the origin, the target. And of course you can use repetition function, but in this case the value will be repeated. One of the common and useful function for you to remember is length, which assess the length of a vector. To subset your vector, you would use single brackets. For instance, if you have vector x, you can slice it by using square brackets, and inside you define 1. In this case, you're extracting the first element. So your first task, you have a vector defined with these numbers. So what elements are extracted in the following four cases? So here I would suggest you to pause the video lecture to calculate and continue to look at the answers. Please compare the answers you obtain with the following answers. And let me know if you have any questions. You can always access Piazza and post the questions. Scalar in R is nothing but a vector of length 1, just one element. But to know and be able to understand the scalar from other quantities sometimes can be important. A scalar quantity has just one magnitude. A vector quantity has both magnitude and direction. So let's look at examples of scalars. For instance, we have a length, we have temperature, we have density, volume. They all represented by a vector of length 1. Compared to a vector quantities, where you notice we have a magnitude and direction. An example of vector quantities are velocity, force, lift, etc. Lists one dimension, but heterogeneous data type. Creation of list quite simple by using list function. And if you notice, in this case, you do have 3 different data types. And if you look at the structure of your list, you notice you have 3 items in the list. They all identify by double square brackets. Inside each of these double square brackets, you have the elements of the list. And each sublist, I would say each element of the list, within itself can contain lists or vectors, multiple vectors. This is an example of using not just 3 unique values, but more variation, and also naming your list elements. The most important to remember when creating a list is just to separate different elements by commas. Now let's subset our list, and there's 2 different options. It's up to you which one to use, and also based on availability of certain information, but you can use double square brackets to extract element from the list by its order, by its indexing, or you can use a $sign. In this case, you would need to use a list where there is a variable defining each element. And to access that variable, you do need to know its name. What is the difference between a single square bracket and double square bracket? It's very simple if you look at the examples. So in the first case, we're extracting the first element, and we're obtaining a lot of things. Consider it's like metadata with the element of the list. We know it's named A, and we know it has a vector, numeric vector. If we subtract list using double square brackets, we're just extracting the element of the list, bypassing all the additional information. So for calculation purposes, more likely you would need to extract just elements of the list. Matrices, remember this is now 2-dimensional data that has rows and columns, but they have to be of the same data type. And also the order of rows and columns is extremely important. And you'll see later that in data frames, this is not important, but for matrices it is. So this is an example of matrix that was built using a colon sign, which just provides sequence of numbers from 1 till 9. It identified the number of row, in this case 3, and number of column, in this case also 3, and it built a matrix. So when we subset 2-dimensional data, we need to specify not just one number, we need to specify row and column. And it is important to remember this very order. Row comes first, column comes next. For instance, in this question, what elements are extracted? Let's do it together. So we have this matrix, 3 by 3. Rows come first, columns comes next. So if we extract element 1, 2, we're extracting element from row 1 and column 2. So we have to look and locate where the row 1 is and where the column 2 is. So in this case, it's number 4. If you'd like, please pause the video and try for yourself to answer question for B and question for C. This is the answers for questions B and C. And make sure you understand how the calculation and extractions of matrices occur. Now let's go to DataFrame, which is a very important topic. So we have a list of vectors of different data types. The only condition we have to follow is the data frame must be of the same length. So that all those vectors that you combine together, they have to be of the same length. That's why the length function is very important to remember, so you can test your data before you combine it. Information about data frame dimension and data type can be actually provided using read_CSV function from reader package library in ARM, as it provides you dimension. In this case, you can see that it's 10 by 3. So you have 10 rows by 3 columns. In addition to column names, it tells you what object type is in each column. So we have integer, we have character, and we have logical. Another way to build DataFrame from scratch, you can use the function DataFrame. You can specify the column names, and in this case, if you notice, you have to use quotation marks, as those are characters, and within each column you have to specify vectors, but it is extremely important to maintain the same length for each vector. Another important thing to remember is that the indexing of each column start with 1, and we'll see in Python it's quite different. So if you use this common function head DataFrame, the name of your DataFrame, you will see that indeed it starts with 1. Let's turn to the Python data structure. Again, let's look at in terms of dimension and data characteristic. There's a slight difference in terminology, but the idea is the same. So for one-dimensional homogeneous data, we use, instead of vector, we call it array, one-dimensional array. In heterogeneous data, it is still list. In two-dimensional data, we use two-dimensional arrays. In heterogeneous, it's data frame. And if you look at those 1D, 2D, and 3D arrays for homogeneous data, you'll see that basically they are the same. What differ is number of axes and how you access them. But recall, all entries in arrays must be of the same data type. To create array in Python, you would use more often NumPy library, which is included in Anaconda if you install it. However, there's additional instruction if you need to install it yourself. Now, to import into your Python session in Notebook, for instance, you would have to use, remember, import library function or statement, which you put on the top. It makes it very more efficient, time efficient. So for instance, when you create array, let's call my array, you would use np. So you're asking for creating array, and within that array parentheses, you specify in square brackets the elements of the array. For 2D, actually, you would have to use the same structure. However, in addition, you have to specify data type. In this case, for instance, NP is built from integer 64. Integer actually can be 32, 8, and other different types based on what you're using. So let's move to a list. So list is created with square brackets, but you notice in this case you have different data types. So we can subset list here with single square brackets. So keep in mind, now you're shifting your attention from R to Python. There's a slight differences in how many brackets or what the names of different functions are. So we are subsetting, for instance, single element. For instance, list 0 will give us this item. Recall that in Python, all elements index starting from 0. So A, B, C, D, this item is actually has location or index 0. If we need a sequence, we would use sequence with the colon between 1 through 3. So we get in elements 1, 2. However, it's not inclusive. That means we're not getting 1, 2, 3 elements. We're getting only up to. So it will be element 1 and element 2 only. All right, and finally, if you need non-consecutive numbers, you would have to use item getter. So operator, you import from operator item getter, and the item getter allows you to specify non-consecutive numbers. Let's look at data frames. So for arrays we're using NumPy. For DataFrame, it is common to use pandas library, which again included in Anaconda installation. And recall again that all the indexing start with 0, which gets more clearly defined here in data frames. So this is just example of head of the table. In DF, in this case, it's just the name of my data frame. So we will have to import again pandas, and typically it's referred to PD. The function to remember pandas is DataFrame, and you can of course for DataFrame use heterogeneous data. So in this case you have string and you have integer, and similar in this case you would have column name. You can define your column name using columns function option. You can create data frame from not only list, you can create data frame from arrays. So you have several arrays, you have 2 arrays here, name and age. And when you start looking through slides after video lecture, I suggest you to go through each command and make sure, each line, and make sure to reproduce it so you are familiar with it. And here's the data frame print function. Now let's look at slicing multiple rows. We use single square bracket, as in this case. We have 1 through 3. We can also select rows and columns. In this case, we would use eloc, location. So we would specify, instead of df1 up till 3, would specify, and remember, first comes rows, second are columns. Right, so we're specifying that we'd like to have rows from 0 up till 2 and columns from 0 up till 2. And finally, if we are aware of labels or column names, for instance, we can use that also instead of indexing. So in this case, we calling or segmenting data frame by the name of the column, which is age. So here's our summary. So we have a scalar, which is just a vector of length of 1. Then we have vector, or 1D, one-dimensional array, as in Python. And we have matrix in data frames, which is 2-dimensional. Just recall in Python it will be 2-dimensional. In R it will be matrix. And data frame is similar, so we have rows and columns. So the question would be, if data frames are more flexible than matrices, why would we use matrices at all? And the same question can be turned into a Python question. If data frame are flexible than 2D arrays, why do we use 2D arrays at all? Well, the answer, one possible answer, because they are much simpler. So calculating with matrices or 2D arrays take much less computational space. And additionally, some functions require matrices or arrays as the input. Finally, let's discuss rectangular data. Have you heard the concept of rectangular data? If not, let's review it. So the typical frame of reference for typical analysis in data science is actually a rectangular data object. Think of a spreadsheet. Think of database table. So DataFrame in Python, that's what it is, rectangular data, or data.frame in R. This is a typical rectangular data object. And a couple of terms that we should review with respect to rectangular data is, first of all, DataFrame. We know now it's a basic data structure for statistical or other type of models. And the feature, which also known under attribute, variable, predictor, or input names, it's a column basically. So based on the literature or based on your project, based on your field, you may encounter mention of features, attributes, variables, or predictors. So those are the synonym of the same semantic concept. Outcome. So in many projects, we're predicting outcomes, right? And a feature, sometimes those features are used to predict outcome in the study. So those outcomes can be also or known under dependent variable name. You may have heard probably in statistics a lot, or response, could be target or output. So in your reports, think of what exactly your audience is, whether you're using feature and outcome or dependent variable and predictor. So think of which terms should you use and be consistent with it. And finally, we have records, which are also known by many other names: case, instance, observation, sample. So record is simply a row in a table. So essentially, rectangular data is two-dimensional matrix where we have rows, which are records, and we have columns, which are features or variables.